And here's some of my original findings, which is pretty cool. The first AFQ I found was 3334. It's a nice momentum with a reset in the cycle at about 2.5. And what you see here is the ability to construct. Imagine you wanted to flip this around, bring this out this way. All you have to do is move these guys around for engineering, for architecture. You're no longer using the square. And forget these in the background. Those are just distracting. These Cartesian orthogonal squares are not what we want, and it's the issue. And so when you are able to arrange 13 segments in a way where, and you got to understand too, these 13 segments, they look right now like they're little pie pieces, but they invert and turn, and they become their individual. If you can see, flip it that way, like take this and turn it so it's now standing up like a teardrop to the center, if you will. But then you pull it out and it's its own circle. Again, this 0.1R void is very important, and we'll cover it as we go along. But I just want to show you some of the original stuff. All right. And here's a note. It says 11:42 p.m. Western Time, 3/12/25. Called the White House. Spoke to the switchboard. Explained, I've made a discovery. She treated me like I was crazy. I asked for a number to call. She said, I have to let you go and take the next call. And did not remember to ask for her name, but I'll call back. You can see how here's where I'm starting to break down my understanding of how to distribute equally. Although we have asymmetrical field quads, we still need to be able to distribute the value of whatever we're specifically pinpointing to something fundamental and foundational. And so you'll see that what I like to do is exemplify my base unit of 1 to a base unit of 10. It's just a more tangible, easier way to work with numbers. But ultimately, it's just one base unit. You can see right here. So what I did was I moved it out of the square altogether. No more square. No more. Okay? And I moved it into this circle. And so our framework has nothing outside of that circle at all. Nothing outside. And what you see here is a kind of behavior that is joint. You can't see it in 2D, but it's joint. And it comes alive with a kind of dynamic nature to it that's just really cool. So it's great for computational, operational systems. It's a new way to program and code and build new cool things. So it's also a cool mathematical framework. And I got field paper that's just like this, but it's circular, right? And I included that in my patent as well for classroom applications. And so what we have here is this circle and radiating and spreading out and through that expansion, if you will, and then through the actual capturing tunnel, this will go through that way, and it will be shoop, shoop, shoop. And through that, you're able to control by having the exact perfect framework that the Photon loves, have the 11 concentric radii over the top of it. And then here's the fun part. Go ahead and start finding some stuff like this. But what you're going to do is you're going to draw out your 13 segments, and then you're going to come lay over it your 11 radii. This is considered one. This is considered the back end of the cylinder, okay? You're going to lay over top in between. So it's 1 and 2. You're going to have 9 in between here, evenly divided. So you'll have a total of 10 spaces, right? And that's your diameter is going to be 10 or a total of 0.1, right? Depending on if you're using 10 or 1. But this is going to be kind of your base. But here's where you really get to start, right here. And we'll carry on a little bit further tomorrow.